Alright, let's continue with example 3. It said, LHS recently started a fencing team. At the third practice, there were 8 students. At the fourth practice, there were 11 students. And at the fifth practice, there were 14 students. The first question says, how many students do you expect would have been at the first practice? So I'm going to start writing out the numbers and see if I can recognize a pattern, and then I can bring it back to the very first practice. So at the third practice, there were 8 students. So that was the third practice. I'll put a little 3 there so I remember. The fourth practice, 11, and then I'll put a little 4 above that. And at the fifth practice, there were 14. So I just basically need to continue the pattern going back the other way to the first practice. So I would have had a second practice here and a first practice here. So I want to see if I can recognize a pattern. So from 14 to 11, going backwards, it looks like I have to subtract 3 going that way, and going this way, subtract 3. I'm only going this direction because I need to get back to the first. So if I continue that pattern of subtracting 3, I can see that this one would have been 5 about at the second practice, and then subtracting 3 would have been an estimation of 2. So how many students do you expect would have been at the first practice? Well, if that pattern continues, there would have been 2 students. B, is this sequence arithmetic, and how do you know? Well, it is, because remember we said if it's arithmetic, you're either adding the same number or subtracting the same number every time. Well, this time, if I look at the sequence 2, 5, 8, 11, 14, and so forth, the reason I know it's arithmetic is because every time I need to add 3. Add 3. As long as you're adding or subtracting the same number, it is arithmetic. So is the sequence arithmetic? I'll answer yes. And how do you know? Because we add 3 each time. And again, as long as you add or subtract the same number every time, then it's arithmetic. Part C says, what is the arithmetic mean of the amount of students at the first practice and the fifth practice? Well, arithmetic mean is just a fancy way of saying average. It means the same thing. And I'm sure you've heard before, mean means the same thing as average. So I just want to find the average of the amount of students at the first practice, which was 2, and the fifth practice, which was 14. So remember, to find the average, you just add the 2 numbers and divide by how many numbers you added. You added 2. So 2 plus 14 gives me 16 over 2. And so the arithmetic mean, or the average between the first practice and the fifth practice, was 8. Okay, let's move on to example 4. Example 4 says, you have a new workout plan to get ready for marathon. On day 1, you are supposed to run 0.5 miles. On day 2, 1 mile. On day 3, you run 1.5 miles. What would you expect to run on day 15? So again, it's extending a pattern. So on the first day, it was 0.5. Second day, 1. Third day, 1.5, and so forth. And I want to know the 15th day. Well, what's the pattern? From 0.5 to 1, I went up by 0.5. From 1 to 1.5, I increased by 0.5. Well, I could keep doing that until I get to the 15th day, which is totally fine. But if you are interested in learning the shortcut, this is what I would do. I would first write the explicit formula. That's what we did yesterday. We wrote the explicit formula. We used that to find a term like the 100th term, in this case the 15th term. So to rewrite the explicit formula, it's a sub n equals a1 plus d parentheses n minus 1. So let's plug in what we know. We know the first term was 0.5. That's how many miles I ran on the first day. Plus your common difference. We got that over here. It's 0.5. These just happen to be the same. It won't always be that way. And then parentheses n minus 1. Okay, let's distribute this 0.5. And combine like terms. Notice something this time. When I have 0.5 and I'm subtracting 0.5, they actually cancel out. And so my explicit formula is just 0.5 times my term number. And that makes sense because on the first day, 0.5 times 1, 0.5. 0.5 times 2, 1. 0.5 times 3, 1.5. So that makes sense. So if I want to know the 15th day, I want to find a sub 15. I would just do 0.5 times 15. So let's see how much that is. 7.5. Yep, because it's really half of 15. So then on day 15, I ran 7.5 miles. And that's if that pattern continued. All right, the next one is a U-try. So right now, please pause the video because it's great to practice problems on your own. So go ahead and pause the video, try the U-try problem, and then when you're finished with the U-try problem, go ahead and restart the video to check your answer. All right, let's go over the answer to the U-try problem. It says, Kellen's dad has been measuring his height every year on his birthday since he was 4 years old. On his 4th birthday, he was 40 inches tall, 5th birthday, 43.25 inches tall, and on his 6th birthday, he was 46.5 inches tall. I want to know what would you expect Kellen's height to be on his 12th birthday. So let's kind of write out what's going on here so that we can recognize the pattern. So on the 4th birthday, 40 inches tall. So on the 4th birthday, 40 inches tall. 5th birthday was 43.25. And on the 6th birthday, it was 46.5. So what is the pattern going on here? From 40 to 43.25, I'm adding 3.25. And I think I see that same pattern there. Yep, add 3.25. So right there is going to be my common difference because that's how much I have to add every time. So it looks like every year he's growing 3¼ inches. So maybe some of you did different things to find the height on the 12th birthday. I'm going to show you a little trick that I would probably use on this one. So I know that every year he grows 3.25 inches. And I know on his 6th birthday he was 46.5 inches tall. So I'm actually going to start with that 46.5 and think to get to his 12th birthday, that's 6 more years. So I am just going to add 3.25. I'm going to add that 6 more times. This is kind of a shortcut I like to take sometimes. So if I did 46.5 plus 3.25 times 6, I find that it would be 66 inches tall. So whether you use this method or the other method of writing the explicit formula first and then plugging in 12, you should both get 66 inches. Then it says, would you expect this pattern to continue? The pattern of adding 3.25 inches every year. Why or why not? Do you still grow 3¼ inches every year? I know I don't. So the reason it wouldn't continue is just humans just eventually stop growing. So would you expect this pattern to continue? No. And I would just say people eventually stop growing. So it's not like we would continue to grow over 3 inches every year. So that's it. Those were the end of the 9.2 Day 2 notes. So now you can get started on your homework. Your homework is a worksheet. So please ask the sub to get the worksheet and you can work on that the remainder of the period. If you have any questions about these notes, you can email me, you can go into MASH, or you can ask the sub and then hopefully they can assist you. So have a great rest of your day and I will see you all tomorrow.